Okay, so in this one we've got triangle ABD shown, and they tell me the area, don't they? 35 centimeters squared. And what's interesting, right? You know, this is not drawn to scale or anything. It's a right angle triangle, and they're telling me the area. Okay, so if we write this down here, right? Area of triangle ABD is equal to 35 centimeters squared. Of course, because it's a right angle triangle, I can use the formula, can't I? Half base times height. And that is what's equal to 35. And we can recognize here that 5 would be my base, okay? And this side here, BD, would be my height, okay? So we can draw on the diagram, and we can call that our base and that our height, because there's a right angle there, and all you've got to do is think of it turning it around, isn't it? So if you turn it around, then you've got yourself a triangle which sort of, you could see that would be like a floor, and then that would be your height. Okay, so as long as there's a right angle there, you've got your base and height. So you know, we use this formula because it is a right angle triangle. We're allowed to use half base height. So we'll have half times the base, which is 5, times the height, which we don't know. Now, the height there, right, is referred to the side BD, isn't it? Okay, so we can call it BD if you want. That equals 35. So then, you know, a bit of calculator work, or half times 5 is 2.5 times BD equals 35, and then BD equals, then, because you times in here, take it over and divide. Okay, so you'll notice I'm taking my time on this and putting all the steps in place using the correct terminology. I'm stating exactly what I'm using here, area of triangle ABD, and then using the formula and using appropriate sort of notation then to represent the length. Okay, just in order for me, I can get the OCW marks. So 35 divided by 2.5, and that comes out to be 14 centimeters. Okay, so I'm going to write 14 in here, and then what you need to do then is notice, of course, we've got another right angle triangle here. Okay, that's really important. We know that this line BD is perpendicular to AC, right? That's what it says here. So that means this has got to be a right angle as well. Okay, so we can state that. We can say, look, BDC is 90 degrees. Okay, so triangle BCD, the one at the top, is right angle. And with a right angle triangle, if we want to work out an angle, we can use SOHCAHTOA, can't we? Okay, we can use SOHCAHTOA because it's a right angle triangle. We're allowed to use that. So with a right angle triangle, of course, H there is opposite the right angle. O here, because opposite the angle I want. And of course my A here then, okay, the adjacent. The two sides I'm going to use are the ones I know. I know H, I know A. Okay, H and A. So when it comes then to SOHCAHTOA, H and A is cos, right? So cos the angle X equals, go in that order, A divided by H. So A is 14, divided by H is 32. And then to get X, of course, then, to get the angle, when you're working at the angle of trigonometry, you take the cos over, don't you? And you do the inverse of cos to minus 1 of that, right? Do this all in one go on my calculator. If you remember, you've got to put, to get the angle, you've got to press shift cos, if you remember that. And it does cos to minus 1 then, and you just put the fraction button, 14 over 32, 32, and then put the arrow across, the replay arrow, and then press your close bracket, and you get your answer 64 degrees, 64.1, isn't it? If we were to be accurate. In terms of decimal places there, we'll put one decimal place, 64.1, and we're done.